All right, let's talk Python. Today, we're going to go beyond the usual suspects, lists and dictionaries, and dive into some seriously powerful data structures hiding right inside Python's standard library. Getting to know these tools can level up your code, making it faster, cleaner, and honestly, way more elegant.
So, have you ever written a piece of code and it just feels clunky, slow? Maybe you're building a giant list and you keep having to add stuff to the beginning, or you've written these long, complicated loops just to count things. We've all been there, for sure. And usually, it's a sign of one simple problem.
Yep, that's it right there. Look, Python's built-in lists and dictionaries are fantastic. They're like the Swiss Army knives of programming. But sometimes you don't need a Swiss Army knife, you need a scalpel. Using a list when you really need a high-performance queue is like trying to use a hammer to turn a screw. I mean, you might get it to work eventually, but it's going to be messy and super inefficient. But here's the good news. Python has you covered. It comes with this incredible built-in toolkit, just packed with these specialized instruments. It's called the Collections module. And honestly, getting to know this module is one of those things that separates the good Python programmers from the great ones. So come on, let's open up this toolbox and see what we've got.
First up, we're going to look at a few tools that are perfect for solving problems with order, counting things really efficiently, and even building more complex stuff like caches.
Okay, so here's a classic scenario. You need a dictionary, but you also need to remember the exact order you put things into it. Now you might be thinking, hey wait, since Python 3.7, regular dictionaries do that now. And you're right, they do. But what if you need more control? What if you need to, say, move an item to the end to mark it as just used? Well, for that, you've got the ordered dictionary. It's like a dictionary on steroids. It doesn't just remember the insertion order, it also gives you special methods to actually reorder items on the fly. And for certain algorithms, this is an absolute game changer.
A perfect example of this is building something called an LRU cache. That stands for least recently used. The idea is pretty simple. Whenever you access something in the cache, you want to mark it as the newest, freshest thing. With orderDict, you just call its move to the end method and boom, it's at the end. Then, when your cache gets full, you know exactly which item to kick out, the one at the very beginning, the oldest, least used one. A regular dictionary just can't do that so elegantly.
All right, next challenge. Imagine I hand you a massive text file, let's say an entire book. And your job is to count the frequency of every single word. How would you do it? I mean, you could set up an empty dictionary, loop through every word, check if the word is already a key, add one to the count, you know the drill. It's a bit of a hassle. But of course, there's a much, much better way.
Let me introduce you to the counter. It's another one of these specialized dictionaries, and its name tells you everything. It is purpose-built for one job, counting things. You can literally throw a whole list of items at it, and poof, it instantly gives you back this perfect dictionary-like object with every item and its exact count.
Just look at the difference here. It's night and day, right? The manual loop works, yeah, but you have to really read it carefully to figure out what it's trying to do. The counter version, though, it's one line, and it practically reads like plain English. You're just telling Python, hey, make me a counter from this list of words. It's so much cleaner, way harder to mess up, and yeah, it's faster too.
Okay, so we've talked a lot about dictionaries. Now let's see how we can give our lists a major performance upgrade.
Python's standard list is awesome. We all use it constantly, but it has a secret weakness, an Achilles heel, if you will. Adding stuff to the end of a list with append, lightning fast. But what happens when you try to insert or remove an item from the beginning of the list? Ugh, it's so slow. That's because Python has to physically shift every single other element in that list over by one. Imagine that with a list of 1,000,000 items. It becomes a huge bottleneck.
The solution to this is a deque. It's spelled D-E-Q-U-E, but you say it like deck, as in a deck of cards. And it's designed from the ground up to do one thing really, really well. Add and remove items from either end, super fast.
So let's just lay it out side by side. A list is fast on the right side, but it's a snail on the left. A deque, on the other hand, is optimized for speed on both ends. It has these append left and pop left methods that are just as fast as their right-sided cousins. So, bottom line, if you're building any kind of queue where items come in one end and go out the other, deque is the obvious choice.
So, we've got simple queues covered. But what about when things aren't just first in, first out? What happens when you have priorities to deal with?
Think about it like a to-do list where some tasks are emergencies and others can wait. You always need to work on the most urgent one first. You could just resort the entire list every time you add a new task, but can you imagine how incredibly inefficient that would be? There has to be a better way, right?
And there is. It's called the heapq module. Now, under the hood, it's using a normal Python list, but it keeps it organized in this really clever way called a min heap. All you really need to know is that this structure guarantees one thing. The smallest item is always at the very first position. This means you can grab the highest priority item instantly, and adding new items is way, way faster than resorting every time. Oh, and if you need the largest item instead, simple trick. Just multiply all your numbers by -1 before you add them.
Okay, so we've seen all these cool tools. How does this help in the real world? Well, these data structures aren't just theoretical toys. They are the secret keys to solving a huge number of common programming problems and coding challenges.
Think of this as your new coding challenge cheat sheet. If a problem is asking for the most common items, your brain should immediately scream counter. If you need to simulate a line, first in, first out, that's a job for DQ. And anytime you see words like priority or importance, you should be reaching for heapq. Recognizing these patterns and knowing which tool to grab is a programming superpower.
And that's really the main takeaway here. Becoming a strong developer isn't just about memorizing syntax. It's about knowing the tools available to you in the standard library and, more importantly, understanding when and why to use each one.
So now it's your turn. Armed with your new knowledge of counter, DQ, and heapq, take a look at your own code. Where could you replace a clunky loop or an inefficient list with the perfect tool for the job? What problem are you going to solve with your new toolkit?